So welcome back everyone. Today we will be doing on a rather short chapter on oxidation and reduction, which is on redox reaction. Every single chemical equation or every single chemical reaction is either oxidation reaction, reduction reaction, or is both a redox reaction. So there's a few methods for you to actually find out whether a chemical reaction is oxidized or reduced in terms of the reactant. The four methods are by oxygen, by hydrogen, by electron, and by oxidation state. So let's go in depth and let's take a look at by oxygen. Look at this example here. Can you observe that the reactant sodium actually gains oxygen, and as a result of this gaining of oxygen, we can conclude that sodium is being oxidized to sodium oxide. So in contrast, if it loses oxygen, then it means that the reactant has been reduced. Now let's look at the next method that we can actually find out is actually by hydrogen. This is the example. Actually you can see that H2S actually becomes S, so it loses 2 hydrogen, and as a result of this is oxidation, is the opposite of oxygen. And in contrast, if you gain hydrogen, that means it's reduction. And the second last method, which is called by electron. If you analyze this equation, magnesium at this point at the very start always start with the reagent. Magnesium at this point has no charge. It initially has no charge, but after a while, after reaction, it becomes Mg2+. That means it loses electron. So the moment you know that if it loses electron, it must be oxidation. In exam situation, they will ask you about they will either give you a method to use, or they will specifically ask you to use one method. Or if they didn't, personally my recommendation is that always use the last method that I'm going to teach you right now, which is on oxidation state. Before you can understand about oxidation state, you must first know how to find the oxidation state of each element itself. For metals, or just pure metals, sodium, iron, all these, they has the oxidation state of 0. For chlorine, H2O2, they also have oxidation of 0. As long as you see only one element in terms of the chemical formula, it will always have oxidation state of 0. And for those that are charged, that means that those are commonly known to us, such as sodium, all these, you know that this is +1, +3, -2. This one we all know. But you cannot assume it in the situation where you want to find the oxidation state of an individual element in that compound, because sometimes you might not be correct due to the situation that the compound is in, or due to the circumstances that the compound is in. It might not be in the oxidation state that you have pre-assumed. So now let's look at example. Aluminium oxide, Al2O3. If we want to find the oxidation state of aluminium, if you want to find oxidation state of aluminium, what I teach my students is always to let aluminium be X. So you draw 2x because of the 2 here, 2 times x. If in the case of a mole, they have a balancing equation, the 2 in front, you don't need to care about 2 in front. So 2 times x plus oxygen 3. Then you can sub in your previous assumption, which is oxygen is -2 equal to 0, and hence x equals to +3. And now let's look at how you find the S inside SO4 2 minus. Let S be X. However, in this case, you will see at the other side equation, instead of being 0, because this is uncharged, now you have actually this is a charged ion, so you have a -2 here, and the same method that it goes about solving, and you will expect to get X equals to +6. So for once in your life, you actually know that sulfur has a charge of +6. In some case, it can actually goes to one single product like this. And please bear in mind, if you are looking for oxidation state, please look for the one that is the same. That means if you are talking about iron here, you must make sure your product also consists of iron. If you talk about chlorine, your product must consist of chlorine. So the iron here has oxidation state of 2+, and at the product is oxidation state of 3+. That means the iron has been oxidized because there is an increase of oxidation state. If there is an increase of oxidation state, it means that it's oxidized. Then look at chlorine. Chlorine, as I say, Cl2 is 0, and Cl equals to -1 in this case here. If you do the mathematical calculation, and you realize that there's a decrease from 0 to -1, hence it's reduced. If both oxidation and reduction occurs, we can say that this is a redox reaction. And for next part we need to know is that what is the difference between oxidizing agent and reducing agent. Look at the same example here. This is also a redox reaction. Analyze the iron here, which is +3. The iron here will be 0. So from +3 to 0 is reduced. So the iron is being reduced. Then let's look at here. From here to here, it increased, so it's oxidized. Okay, and so for you to understand what's oxidizing agent and reducing agent, you must know that this is being oxidized. So this carbon monoxide is being oxidized. So why is this carbon monoxide being oxidized? It's because of this thing next to it, which is reacting with it. So hence making this an oxidizing agent. And in contrast, this will become a reducing agent. So all oxidizing agent reduces itself to oxidize others. And all oxidizing agent reduces itself to oxidize others. But all reducing agent oxidize itself to reduce others. I know it's a bit confusing right now, but with further practice you will get a good hang of it. Remember, that's the opposite. Oxidizing agent reduce itself. Okay, then look at some of the example for you to actually find oxidizing agent. For oxidizing agent, the most common one is to add potassium iodide, which is which at the start is a color. Before you add, it will be colorless. After you add, a displacement reaction will occur. Hence, the iodine will be displaced, and you will see a brown solution. Hence, it will turn brown. Another method is actually you can use to test oxidizing agent is just carry out your normal chemical reaction and do the method that you use here to actually find out. Now we'll move on to how you actually can test for reducing agent. For reducing agent, there's two conventional way, which is you add acidified potassium dichromate, chromate, it turns orange to green, or you add acidified potassium manganese, it will turn purple to colorless. For this type, you don't need to know the index of the equation, but you need to have a rough idea of how the color changes, and you must know that if I add potassium dichromate, what am I trying to test here? I'm trying to actually find out a reducing agent. So if I'm trying to find a reducing agent, then the character that I'm playing right now in this case is an oxidizing agent. So with that, I come to the end of the lesson. Thank you.